Hello, I am Luis Herrera, and today I'll be presenting my project that I've been working on for EE147. The goal for this project is to run and apply an edge detection filter onto an image. The focus will be on the performance difference between a CPU and GPU based solution. GPUs have an advantage handling parallel workloads, and within image processing applications, GPUs should be more efficient than CPUs. So, let me fix this real quick. The edge detection filter will be used on images stored as ppm files, and it will output the result using the ppm format as well. Within the GPU implementation of the filter, the acceleration that the GPU provides comes from the parallel program developed to utilize multiple threads. Tiling and use of shared memory were not applied in this project, which leaves room for improving performance in later iterations of this program. The primary focus is to compare the performance obtained from implementing parallelism into the algorithm. The edge detection filter works by applying a mask onto every pixel of an image. The mask chosen for this program is a 3x3 mask. Each pixel is calculated by the result of the convolution performed with the mask shown below in Figure 1. This calculation has to be repeated for each pixel. So this is where we implement the parallelism of inside of a GPU, and this here is the mask that I'll be using for the edge detection filter. The way that this works is by multiplying these coefficients to its corresponding pixel values, and then we add all of those pixel values to find the final result for the middle pixel here. This has to be repeated for every single pixel, and this is where this is where the GPU would outperform a CPU. So running the program, I'll be running the program inside of Visual Studio's debugger. The image used was a ppm file type, type P3. This is important because the program only works with this file type as it stands right now. So the results that I previously got or measured are here shown in Figure number 2. The results that we are more focused about are the execution times for applying the edge detection filter on the CPU and GPU. So for the CPU, it took 113 milliseconds to apply the filter onto the image, which is shown right here in the image. And for the GPU solution, it only took 44 microseconds to complete the application of the edge detection filter. Note that these values do not measure the time it took for the memory to be transferred from the host to the device or from the device to host. The only time that we're measuring here, or the only time that we are focused on, is on the execution time for applying the convolution mask of the edge detection filter. So this is a screenshot of the console. This is the original image that I will be using and applying the edge detection filter onto. And before I show you the next images, which are the outputs, let me quickly just show you the time it took for the program to read the image file and to build the output images. So the program took 36 seconds to read all the values of the image file from the original image, which is down here in Figure number 3. And it took 19 seconds to build the first image, which is the CPU solution, and it took a total of 18 seconds to build the second image for the GPU solution. So the build time is really similar. This is because it's being run on the CPU. The only thing that we're executing on the GPU is the application of the manipulation of the pixel values with the edge detection filter, which only took 44 microseconds. Alright, so if we go down here to see the results of the images, this first image is the output image from the CPU. So as you can see here, the edges of the image are detected and they are being highlighted. And then for the GPU, it's the exact same image because at the end of the day we are applying the same filter. The only thing that changes is the algorithm behind it, but it's the same result as the one above. Problems faced during the development of this program. Developing the CPU solution for this developing the CPU solution was more difficult compared to the GPU implementation, and that was because I was not familiar with the ppm file type. So I had a really hard time storing and reading variables from the file. Also, there's multiple types of file formatting within the ppm um, format. There's a total of 6 types, and for this application, I am only using the P3 file type. And yeah, so in conclusion, in this report, the goal was to compare the differences in performance for an edge detection filter between CPU and GPU, and this says an image with width 1616 and a height of 1080 was used. The results showed that the CPU solution took about 113 milliseconds to apply the filter, while the GPU only required 44 microseconds to complete the task. In this example, the GPU was over 2,000 times faster than the CPU, but do note that only the execution time for applying the filter was being compared. So this is my report for this, and let me show you a quick demo showing that this program does work. So let me run this real quick. So on the top of the console, you'll see P3 is the type of the image, 1616 is the width, 1080 is the height, and the resolution of the RGB values is up to 255. So right now it is loading it is reading the file and storing the values inside of a array. This takes about 30 seconds usually. So it is not done reading the image. It took 38 seconds in this test. It is going to start applying the edge detection filter using the CPU solution. This in itself takes about 16 seconds because it also builds the image at the same time. So the time to apply the filter took 114 milliseconds, and the time to apply the filter and build the image was a total of 18 seconds. The GPU solution only took 48 microseconds in this test, and right now the output for the GPU is being built, which took a total of 19 seconds. So this was the original image. Figure 3 was the original image. Figure 4 is the image produced by the CPU, and figure 5 is the image produced by the GPU. And yeah, this is my project. Thank you for listening, and that's all. Thank you.